So CPU scheduling algorithm. So overview, basic concept, what is meant by scheduling, what are the different algorithms, then criteria for uniprocessor, means only one processor is there. So scheduling criteria. So this is again one important point regarding to the scheduling criteria, means for uniprocessor is having only one process. Then scheduling algorithm implementation in C++. You are having one practicals of CPU scheduling. Then examples, demonstrations means your example, how to calculate the average waiting time and turnaround time. Last point is the involvement of operating system in CPU scheduling. So basic concept, main objective of multi-programming is to keep on running processes all the times for maximum CPU utilization. This one, your CPU should be continuously busy. It should not be idle. So in multi-programming so main objective of multi-programming is to keep on running processes all the time for maximum CPU utilization. In multi-programming, we are executing more than one program. So your processor should be continuously busy. That is required in a multi-programming. So scheduling is a fundamental function of operating system. So what is function of scheduling, or what is scheduling? Means assigning the process to the processor. That is a function of scheduler, CPU scheduler. The task of selecting the processes in the memory that are ready to execute and allocate them to the CPU is performed by the CPU scheduler. That we have studied in the last lecture. Three types of schedulers are there: long term, medium term, and short term. So the function of CPU scheduler is what? Whichever process are ready, assigning that process to the processor for the execution, or assigning that process to the CPU for the purpose of execution is nothing but the function of CPU scheduler. Now, CPU scheduler, CPU scheduling decision may take place when the process, so we have studied which are the life cycle of process. So switches from running to the waiting state. Your process will switch from running state to the waiting state or going to the waiting queue. Second one is switches from running to the ready state. Okay, running to waiting. Second one is running to ready state. Why waiting state? It requires some IO operation, so that purpose is to go to the waiting state. Okay, and in ready state, running to ready state. So again, when IO operation is complete, it is going to the ready state. Then switches from waiting to ready state, from waiting queue to ready queue, and last one is the terminates, means the process will be finished the execution, so it will go into the terminate state. Now scheduling under 1 and 4 is a non-preemptive, means what? It should run for completion. We cannot preempt that process, so that is called as a non-preempt. Means what? Suppose your process P1 is running, so it requires 10 milliseconds. So it should run for 10 milliseconds. Complete execution. We cannot preempt or we cannot stop the execution of that process. That is called as a non-preemptive. And other scheduling is a preemptive. Means suppose any higher priority process comes or some interrupt occurs, at that time the process is current running process is stopped, and that higher priority process is given a processor for execution. So that is called as a preemptive. So these are the two types now: non-preemptive and preemptive. So preemptive process can be stopped. Non-preemptive process cannot stop the execution till it gets completed. Now, CPU scheduler. So non-preemptive and preemptive. So these are the two types in which the algorithms are divided. So non-preemptive, once the process is allocated to the CPU, it does not leave unless. Okay, means we cannot stop that process unless it has to wait for IO request or it gets terminated. Okay, means final execution of that process is finished, only that process will be stopped, means after execution only. And second, first one is which one? It has to wait, for example, some IO request. So it will go into the waiting queue. So that is with non-preemptive, means we cannot stop that process. In simple language, suppose you are traveling from Kopargaon to Yeola. So there is no any stop between that. Okay, so that process cannot that bus cannot wait at the any location. So this is what non-preemptive. While preemptive, second one is a preemptive. So OS can force preempt a process from CPU at any time. Means we can stop that process. Suppose any higher priority process come, that process will be stopped. So that is what OS can force or preempt a process from CPU at any time. Example, to allocate CPU to the another higher priority process. Okay. Means here higher priority process come, at that time we could stop that process, and that processor should be given to the higher priority process. So these are the two types, preemptive and non-preemptive. Okay. Then scheduling criteria for uniprocessor, only one process. So CPU utilization. So keep the CPU as busy as possible. Means continuously CPU is 100%. If it is executing for 1 hour, so we require the process for 1 hour. It is continuously executing for 1 hour, means what? CPU utilization is the maximum. For that 1 hour, the CPU is not idle. So we can say that processor is continuously running. So that is called as a CPU utilization, continuously executing. Second one is a throughput. So first one is CPU utilization, it should be maximized or maximum. Throughput, number of processes that completes their execution per unit time, per unit time. So that is a throughput. How many processes get executed on a processor for the per unit time or per second, that is called as a throughput. Number of processes that complete their execution per time unit. So that should be again maximized. So that is called as a throughput. Okay. Then third one is your turnaround time. Now listen this definition are important. Turnaround time and waiting time. So what is turnaround time? The amount of time to execute a particular process. Okay. The time from submission to termination. This what happens, that process time, which is time when that process come into the waiting queue, and when that process get executed, complete execution, that is called as a turnaround time. Are you getting this? This what happens here. I'll give a real time example. Suppose your college time is 10 o'clock. Okay. And 10 to 11, my lecture is there. Suppose OS lecture 10 to 11. But you came into the class at 9:30. Okay. You came in the class in a 9:30. So what is your turnaround time? 9:30 till your 11 o'clock. So that is called as a turnaround time. Getting it? Means from 9:30, means your waiting time is how much? Half hour. Because you are waiting from 9:30 to 10 o'clock. Half hour, and 10 to 11, my lecture is there. So how much is your turnaround time? Waiting time plus your execution time. So that is called as a turnaround time. Okay. So we have to calculate this turnaround time. It is called as a turnaround time. So turnaround time is minimized. Then waiting time. So what is waiting time? Amount of time a process has been waiting in a ready queue. Waiting in a ready queue. It is a sum of time waiting in a ready queue. So that is called as a waiting time. Which time is here now? Waiting time. Suppose you are coming in the class at 9:30 and my lecture started at 10 o'clock. So what is waiting time? Half hour. That is called as a waiting time. Then response time, amount of time it takes from when a request was submitted until the first response is produced. It is not output. It is a first response. Means if you are given the response time is what? Whenever the process is given to the processor, and when the first response of that output is user getting or getting the output, first response is called as a response time. It is not completion time or complete output. Means what? Final output is not got to the user, so that is not response time. When the first instance of the output is user get, that is called as a response time. Okay. Now these are the scheduling algorithm. First one is your first come, first serve. Second one is the shortage of first. Third one is your priority, and last one is your round robin. Now what is first come, first serve? Whichever the first process come into the queue, that process will get the processor for execution. That is called as a first come, first serve. Okay. Then this what? Suppose you are having P1. We'll see the examples. Basically, go for the examples how to solve. Means what is FCFS, what is shortage of first, what is priority, and what is round robin. In simple, whichever process first come into the queue, that process will be executed first, or that process will get the processor first. So that is called as a first come, first serve. Means here what is there? Arrival time is considered. The second one is your shortage of first. What is shortage of first? The execution time of that process is smaller. That process will get the processor for execution. That is a shortage of first. The third one is a priority. Means here we are assigning the priority column. Lowest number, highest priority, or highest number, lowest priority. That will define in your problem definition. Means lowest number is having highest priority. Means 0 will have highest priority, then 1 will have, 2 will have, 3 will have, whatever may be. Lowest number, highest priority, or highest number, lowest priority. That will define in a problem definition itself. And last one is the round robin, in which we are giving the time slice of 1 millisecond, 2 millisecond for each and every process. So equal chance will be given for each and every process for execution. That is called as a round robin. So implementation is C++. That we'll see in practical hours. So here comes the problem. FCFS, first come, first serve. So listen here. So what happens here now? We are having a process. So P1, P2, and P3, and burst time or the execution time. Burst time or execution time. So P1 requires how many milliseconds? 24 milliseconds. Okay. P2 requires how many milliseconds? 3 milliseconds. And P3 requires how many milliseconds? 3 milliseconds. So this much time is required for process P1 for execution on a processor, 24 milliseconds. Okay. Suppose that the process arrived in order. Now it is which one? First come, first serve. Which process come first? P1, P2, and P3. So P1, P2, and P3. So we have to draw the Gantt chart. Okay. Gantt chart for scheduling. Means you have graphical representation of that process. So what is here now? P1 starting with 0 to 24. So this process, and this is what? Non-preemptive, means we cannot preempt. FCFS is a non-preemptive algorithm. Getting it? First come, first serve is a non-preemptive algorithm. Means here what happens now? P1 comes. So P1 0 to 24. So 24 millisecond is assigned to that processor for P1. Now after P1 completes, second process arrives which one? P2. First come, first serve. Now P2 arrives. So how much time is required for P2? 3 milliseconds. So 24 plus 3, 27. Okay. Then P3 comes. So P3 comes at 27. This third comes. So it is what? 27 plus 3. It is 30. So this is a Gantt chart. So 1 mark is for Gantt chart. 1.5. So 1.5 mark is for waiting, calculate the waiting time, and 1.5 mark is for calculating the turnaround time. Waiting time and turnaround time. So this problem comes for 4 marks. Okay. Now we have to calculate what? Waiting time. So what is the waiting time of P1? 0, because it comes first, other comes at a 0 and got the processor at 0. So waiting time of P1 is 0. Okay. Now P2 is how much? 24. Okay. After completion of P1, the processor is allocated to P2. So it is 24 here. Got the processor at 24. After completion, so it is which one? P2 is 24 and P3 is how much? 27. Okay, waiting for 27. So it is waiting for this much time. So it is 27. So average waiting time is how much? 0 plus 24 plus 27 divided by 3. It is 70. So this is called as a waiting time. Average waiting time. What is then turnaround time? We have to calculate the. Now this second example is there. Suppose the process are in order P2, P3, and P1. So first come first. So which process come first? P2. Which came second? P3. And then came your P1. So what happens here now? P2, P3, and P1. The Gantt chart is P2, P3, and P1. So what is the waiting time of P1 now? this here, P1 here means how much? 6. Got the processor at 6. Then P2 is how much? 0. And P3 is how much? 3. So again, average waiting time is 6 plus 0 plus 3 divided by 3. So how much it is? 3 milliseconds. So much better than the previous case. Previous case it was what? 17. Okay, means what happens here? Suppose any process is having require more time and second process requires small time. So that small process will require to wait for more time. So this is what long process, short process will require more waiting time than long process. So we shall finish here what? Average waiting time is how much? 3. So convey effort short process behind long process. This is should execute minimum size process should execute first and maximum size process should execute next one. So that is disadvantage of first come first serve. Okay. Have you got this one? How to calculate the average waiting time? Now turnaround time. So we'll solve the turnaround time here. Now what is turnaround time? Waiting time plus your execution time. So that is called as a turnaround time. So we'll go for turnaround time.
Yes, sir. What is the color?
Listen here. So calculation of average turnaround time. So we have finished which one? Waiting time. Now we'll go for the turnaround time. These are execution time. So what is your process P1, P2 and P3? Whether it is visible? Okay. So we'll solve the one example to calculate the turnaround time. So what is the execution time or burst time of P1 was 24. Then P2 is how much? 3. And P3 is also 3. Okay, so this is what burst time or execution time of P1, 24, P2 is 3 and P3 is 3. Now what we have to do? Calculate the turnaround time. So again, we have drawn the Gantt chart. So P1 0 to 24, P2 is how much? 24 to 27, and P3 is again 3 milliseconds, 30. So this is your Gantt chart. Okay. So waiting time we have already calculated. Now we'll go for the turnaround time. So what is the turnaround time for P1? It is waiting time plus execution time. When it will get execution, 24 milliseconds. So it will be what? 24. Okay. Then for P2, again it came at 0, 24 to 27. Means how much? 27 milliseconds, because it get executed at 27. Getting it? And last one is your P3. So it get executed at the 30 milliseconds. So it will be 30. Getting it? This side, right hand side of your, that is called a execution time, and this is your waiting time. So waiting time of P1 was 0, and P2 is how much? 24. It has wait for this much time. Then it got the processor at 24. So this is the waiting time, and waiting time for P3 is this much, 0 to 27. Now turnaround time is which one? Time required for execution of that process. That is called as a turnaround time. So how much it is? 24 for P1, 27 for P2, and 30 for P3. So how much it is? 24 plus 27 plus 30. 81 divided by 3. 81 divided by 3, how much? 27, no? 27 milliseconds is your waiting time, average waiting time. Average waiting time is how much? 24 plus 27 plus 30. So it is 81 divided by 3. It is 27 milliseconds. So this is called as the average waiting time for P1. Average waiting time for your process. And our waiting time for P1 is 24, P2 is 27, and P3 is 30 milliseconds. Okay. Got it?
Yes, sir.